Hello guys, hello. Hope you people are very much energetic and getting prepared for the JEE and NEET in coming September month. Today here I am with a special points. Here I have written 6 points. I suppose you can see it. You can see it? Visible? Okay. Paramagnetic, diamagnetic, bond order, stability, magnetic moment and low spin, high spin. I have written 6 points. And before writing the 6 points, I was thinking that I should write a few points where from my students or the students across the country should get at least one question in their coming JEE or NEET exam. I am 99% sure at least one questions from these 6 points you will be getting in your coming NEET or JEE main exam. 99% sure. Could you follow? 99% sure you will be getting a questions, at least one question based upon this 6 point concept. I hope you know that. These things, regarding all these things, I know you people have sufficient idea. But I am going to give a brief discussions from which you can correlate the points with each other. Correlate the point with each other. Suppose if I consider the paramagnetic and diamagnetic, what kind of questions can be asked? They will be giving 2-3 spaces. They will be asking identify the paramagnetic or diamagnetic compounds. Even they can ask you find out the magnetic moments. They can ask you which one is the low spin complex or high spin complex. All these 4 points, red colored 4 points, paramagnetic, diamagnetic, magnetic moment, low spin, high spin, can be correlated with a single concept. Suppose you want to identify the paramagnetic compounds. I hope you know the definition of paramagnetic compounds. The compound which is attracted by the magnetic field and for which the basic condition is what? Presence of unpaired electrons. Am I right? Yes. And for diamagnetic, what is the basic concept? Absence of unpaired electrons. For paramagnetic, the basic condition is presence of unpaired electron. Presence of unpaired electron. Presence of unpaired electron. This is the basic condition. And for this, absence of unpaired electron, you know all these things, unpaired electrons. And this magnetic moment, you know, I suppose, it relates with the number of unpaired electrons only, square root of n into n plus 2, n into n plus 2, Bm. Bm is what? Bohr's magneton. And what is n here? What is n? It is unpaired electrons. N is number of unpaired electrons. Number of unpaired electrons. Unpaired electron. And what is low spin, high spin? This is also related to number of unpaired electrons. What is spin? Spin is equal to n by 2. What is n? Number of unpaired electrons. All these 4 concepts based upon the number of unpaired electrons. If there is number of unpaired electrons, the compound will be paramagnetic. If there is no unpaired electrons, it will be diamagnetic. If there is no unpaired electrons, magnetic moment will be 0. If there is no unpaired electron, net spin also will be 0. You can relate how important the unpaired electrons here. Am I right? You need to identify the unpaired electrons. If there is unpaired electrons, I am again telling it is paramagnetic. If there is unpaired electrons, we can calculate the magnetic moment. If there is unpaired electrons, we can calculate the spin. If no unpaired electrons, it will be diamagnetic, magnetic moment will be 0, spin also will be 0. Now my question, how to calculate unpaired electrons? That is the basic things, unpaired electrons. Clear? The point clear? We need to relate all these 4 points, paramagnetic, diamagnetic, magnetic moment and low spin, high spin with unpaired electrons. Now how to identify whether there is unpaired electrons or not? Okay, let us see. Questions can be given like this. Suppose you have Na plus, Mn2 plus, scandium 3 plus, or even questions can be given like potassium oxide, even it can be given as potassium peroxide, even questions can be given suppose CuCl, and they are asking to identify paramagnetic compound, diamagnetic compound, even we need to calculate the magnetic moment and low spin. Questions can be given in terms of atomic forms or ionic forms, or it can be given in terms of compound form. Now, if it is given in terms of atomic forms or ionic form, let us consider another atom, Cl atom, or let us consider zinc, pure atomic form. Questions can be given in atomic form or the ionic form or in compound form. They may ask identify paramagnetic compounds, diamagnetic compounds, or they may ask to calculate the magnetic moment, or they can ask to find out the total spin. Everything should be related with what? Number of unpaired electrons. How to do calculate the number of unpaired electrons for the ions or the atoms? I suppose you know that. What we should do? We should write their electronic configuration. For atoms or the ions, we should write their electronic configuration. Suppose in case of Na plus, what is the electronic configuration? What is the electronic configuration? Yes, it is 1s2, 2s2, 2p6. If I write in the box model, I suppose you know all this concept. Box model, this is 1s, this is 2s, this is 2p. One box may have maximum 2 electrons with the opposite spin. In Na plus, there are how many electrons? There is only 10 electrons. Is there any unpaired electrons? Unpaired means one box contains 1 electron. That's I say unpaired. If one box contains 2 electrons, that's I say paired. Is there any box which contains only 1 electrons? No. All box contains 2 electrons. Therefore, in this case, there is no unpaired electron. In this case, there is no unpaired electron. That means Na plus is diamagnetic. Na plus magnetic moment is 0. Na plus total spin will be 0. Suppose if you talk about the manganese, Mn2 plus, manganese, what is the atomic number? 25. 25. In case of manganese, electronic configuration is what? 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 5 and 4s2. You know that I suppose 25 electrons, 2, 4, 10, 12, 18, 23, 25. Am I right? But here it is not manganese, here it is manganese 2 plus. That means 2 plus means what? There is loss of 2 electron. This 2 electron is lost. Always loss of electron take place from the outermost shell. Here the shell, I suppose you know this is the shell, 4th shell, and this is the 3rd shell, this is the 2nd shell. That's why this is the outermost shell. Outermost shell. Loss of electron take place from the outermost shell. How many electrons lost? 2 electrons. Therefore, this 4s contains now 0 electron. 4s contains now 0 electron. 0 electron. From this configuration, you can see this 1s2 box is fill up, 2s2 box is fill up, 2p6 box is fill up, 3s2 box will be fill up, 3p6 box will be fill up. For 3d5, if you write that box model 3d5, you know how many subshells is there? How many orbitals are there here? 5. 3d5. Here 1, 1, 1, 1, 1. You see there are 5 unpaired electrons. 1, 1, 1, 1, 1. You know that you should fill up first one by one. That's called Hund's rule of maximum multiplicity. You know that? Yes. First 1, 1, 1. Then only pairing take place with opposite spin. Therefore, there are 5 electrons, 5 box. We should fill up 1, 1, 1, 1, 1. No extra electron for the pairing. Therefore, number of unpaired electrons is 5. Yes, number of unpaired electrons is there. Compound is paramagnetic. And we can calculate the magnetic moment. I told you the formula of magnetic moment, mu is square root of n into n plus 2. Bohr's magneton, this is the unit. N is 5, we can put the value and calculate the magnetic moment. And total spin, we know S equal to n by 2. N is 5, 5 by 2, 2.5, we can calculate the spin also. Clear? We can calculate paramagnetic, diamagnetic characters, magnetic moments and low spin, high spin from the unpaired electrons. Now let us consider a compound. Let us consider a compound. I suppose you can do the rest of the things. Same. First you need to write the electronic configuration. Then you need to check whether any box is there containing single electrons. If any box is there containing single electrons, that means it is the unpaired electrons. If there is unpaired electrons, it is paramagnetic. No unpaired electrons, then diamagnetic. And putting this n values, we can get the magnetic moment. From this formula, you can correlate. For diamagnetic compounds, magnetic moments always will be 0. For paramagnetic compounds, magnetic moments will be greater than 0. Okay? For compounds having a spin greater than 0, always will be paramagnetic. We can relate with that. Sure? Now let us consider how to do for a compound. How to do for a compound. First, consider this one. CuCl. You know this is a salt, ionic salt. This CuCl, how it is formed? It is formed due to Cu plus and Cl minus. Am I right? Now we need to write the electronic configuration for these ions and these ions separately. And any one of these ions, if contains unpaired electrons, then it will be paramagnetic. Then we can calculate the magnetic moment. From that number of unpaired electrons, we can calculate the total spin. Any one of these, if both the ions contains no unpaired electrons, in that case only it will be diamagnetic. In that case only magnetic moment will be 0. In that case only spin will be 0. Here if you write the electronic configuration of copper and Cl minus, I suppose you know that in case of copper it is 1s2, 2s2, 2p6, 3s2, 3p6, I suppose 3d10. Am I right? Copper is 29. Here there is a loss of 1 electrons. Therefore now it contains 28 electrons. Check it. 2, 4, 10, 12, 18 plus 10. There is 28 electrons. Is there any box which are singly filled? No. There are 10 electrons in D. For D orbital there are 5 boxes. Each box contains 2 electrons. That's why total electron in the D is 10. Therefore no box is half filled or no box contains single electrons. Therefore number of unpaired electrons here for this is 0. Similarly for Cl minus, for chlorine atomic number is 17, but here is minus. Minus means what? There is extra electron. How many extra? 1 minus means 1 extra electron. Therefore it contains only 18 electrons. For 18 electrons, what is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6. From this you can see number of unpaired electrons 0. There is no box which is half filled. Therefore both the ions contains no unpaired electrons. That means this compound is diamagnetic. Magnetic moment will be 0. Spin also will be 0. Sure? But if you come to this case, let us this case, I will be coming this at the end. This I will relate with the other two concepts also. Coming with this. In this case what will happen? I suppose you know that when this K2O break down, it breaks into K plus and O2 minus, 2K plus and O2 minus. This is K plus, potassium we know, it can have only plus 1 oxidation state. Therefore, there were 2 potassium, 2K plus and oxidants, only 1 oxidants. To nullify these 2 positive charge, 2 negative charge here. Now if we consider this is nothing but it contains now 18 electrons. Like this, it also contains 18 electrons. If there is 18 electrons, number of unpaired electrons 0. Same electronic configuration. Similarly, if you consider this, there is now 10 electrons. 10 means it is the electronic configuration of the neon. Neon, 10 electrons. Here there are only 10 electrons. 10 means what? 1s2, 2s2, 2p6 up to this. 10 electrons. Is there any box which are half filled? No, all are completely filled. Therefore, here also number of unpaired electrons 0. Here also number of unpaired electrons 0. Therefore, these compounds will be your diamagnetic. Magnetic moment will be 0. Total spin also will be 0. But how to do this? Potassium peroxide. How to do that? Very important. Please, I am going to relate with the other concept also. This potassium peroxide. You know this potassium peroxide. When break down, it break down into like this. Twice K plus O2 2 minus. O2 2 minus, because you see potassium has only plus 1 oxidation state. All alkali metals, group 1 metals can have only plus 1 oxidation state. And there are 2 potassium, therefore 2 positive. To nullify this 2 positive, we should have the 2 negative charges on the other ions. There are 2 oxys. Charge here 2 positive, here should be 2 negative. Now, this is in molecular form. O2. This is in molecular form. This is in molecular form. This is in atomic forms or their corresponding ionic form. For this, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6 because it contains 18 electrons. 18 electrons. This is for the atoms or the ions, but this is for the molecules. For molecules, what electronic configuration we should consider? This is for atoms. Atoms for atomic orbitals. Atomic orbital is sp,df. Am I right? But for molecular forms, what electronic configuration should follow? We should follow molecular orbital electronic configuration.